Welcome back. We are doing Unit 3 now. In class we did Unit 3 Lesson 1, which is about interior and exterior angles. And today we're doing Lesson 2, which is about isosceles and equilateral triangles. This word isosceles has a pretty funny spelling, and it's important that you do know how to spell it, so make sure you're careful when you copy it down. And then once you're ready, go ahead and turn to a fresh page in your notebook. All right, so go ahead and put today's date. This is Unit 3, Lesson 2. And the essential question today is, how do I solve problems involving equilateral and isosceles triangles? Go ahead and pause if you need to get this down. So we're going to talk about equilateral triangles first, just because they are a little bit easier. An equilateral triangle is exactly what you think it is based on its name. Equilateral, let's write it. So equal, it's spelled a little differently, but it means equal. And then lateral means side. And so an equilateral triangle is a triangle where all the sides are equal. So an equilateral triangle has 3 congruent sides, and it has 3 congruent angles. So let's go ahead and sketch an equilateral triangle. Something like this. Go ahead and use a straight edge whenever you can to make your diagrams look nice. So mine is not perfect, as you can see. I don't think I drew it so that every side is equal, but we're just going to mark it to show that they are. So we're going to show that these 3 sides are all congruent. And then 3 angles are congruent, but because this is a triangle, we know that the 3 angles add up to 180. We'll go ahead and mark that the angles are congruent. But we can actually figure out exactly what those angle measures are, because if they add up to 180 and they're all the same, go ahead and think about how you could find the measure of each angle. And hopefully you figured out we can just take those 180 degrees and divide them equally among the 3 angles, and we'll get 60 degrees. And so in any equilateral triangle, all the angle measures are exactly 60 degrees because they have to be the same. 60 plus 60 plus 60 is 180. So let's go ahead and do a quick example with an equilateral triangle. Example 1. We want to find the length of side AB in the triangle below. So draw yourself something that is, I broke my own rule and I'm not using a straight edge, something that looks sort of like an equilateral triangle. We're going to go A, B, C. And then we'll say that this length right here is 6x minus 5 units long, and this length here is 4x plus 7 units long. And what we want to do is find the length of AB. So I'm going to zoom in here. So whenever we're doing problems like this, and the assignment on this lesson is basically just a full page of problems like this, where you have to use some algebra to find the missing information, and the first step has to be to write an equation. So we know information about these two sides. We also know that all three sides are congruent, and that means, of course, that these two sides are congruent. And so I'm going to start by seeing if I can write some equation involving both of these expressions. And since this side equals this side, I can simply write the equation 6x minus 5 has to equal 4x plus 7. So please take a minute to solve that equation and see what you get. Keep solving. So hopefully you got x equals 6. And I will say be really careful and make sure you answered the question that was asked. The question says find the length of AB. We found that x equals 6, but that is not the length of AB. The length of AB is going to be the same as the length of this and the length of this. And all we know right now is the value of x. So to find the length of AB, and it's really important that you write this down so that you're really clearly communicating on paper what you're thinking. The length of AB is equal to both of these other lengths. And so what we're going to do is choose one of these expressions, really whichever one looks easiest to you. And to me, it's that one. And we're going to write it down. And instead of the x, I'm going to use, so I'm just going to draw a little arrow to show where that came from. And I'm going to use the 6 because I now know that the value of x is 6. And so I should get the same answer as if I had replaced this x with 6, right? Because all three sides are the same. So 4 times 6 is 24. And 24 plus 7, if I'm doing my math right, is 31. And so that means that AB is 31 units. So AB equals 31. That's our answer. And we should get the same answer with both of these. And you can just really quickly double check. If I replace this x with 6, 6 times 6 is 36, minus 5 is 31. So all three sides are 31 here. So that's the type of problem you'll see. You'll need to write equations to find missing information. So that is an equilateral triangle. The next kind of triangle we're going to talk about is an isosceles triangle. Isosceles triangles are really important. They come up a lot. We're going to sketch an isosceles triangle, and then we'll talk about the various properties of it. So an isosceles triangle has a base, and the base, I'm going to draw it at the top. The base does not have to go on the bottom. Sometimes we think because it's called a base, it has to go on the bottom, like the base of a pyramid of cheerleaders or something, but that just isn't the case with figures. We can rotate them. And then it has two sides that are congruent. So the base, I'm going to label this base, and then two sides that are congruent. And so I'm going to just find kind of the midpoint. I'm not going to mark it. And I'm going to come down quite a ways just so that you can see visually that these two sides I'm about to draw are different from the length of the base. Okay. And these other sides, the ones that are congruent to each other, are called the legs. So this is a leg, and this is a leg, and the legs are congruent. So in an isosceles triangle, you have one base, and then you have legs that are congruent to one another. And it turns out, you can sort of see it here, it's obvious when you think about it, but in an isosceles triangle, when you have two sides that are congruent, you also have two angles that are congruent. And so we're going to mark those. These angles are congruent, and those are called the base angles. And they're called the base angles because they are the two angles surrounding the base. This other angle here will be a different angle measure, and this angle is called the vertex angle, and this point up here is called the vertex. So those are the pieces of an isosceles triangle. There's a theorem here that says if two sides of a triangle are congruent, then the two base angles are congruent, and the converse of that is also true. So, for example, if we draw a triangle, let's draw a triangle like this. So try to make yours look like mine. And if I tell you that those two angles are congruent, then without needing to get out your ruler or anything else, we know automatically that these two sides are also congruent. So if a triangle has two sides that are congruent, we know that it has two angles that are congruent, and then the converse of that is also true. If two angles are congruent, then we automatically know that the two legs are going to be congruent to one another. So that's the important information about an isosceles triangle. We're going to turn the page and do just a couple of examples. Well, I'm turning the page. I don't know if you are. Leave space for a summary. So this will be example 2. Find the measure of angle T. And remember, if you see that measure, then we're looking for a number as an answer, right? Find the measure of angle T. And we're going to draw an isosceles triangle here. I'm going to make mine 6 units long if you're trying to make yours look like mine. And then I'll make the height of the triangle 2 units and I'll complete it. Okay. RST is our triangle. And we know that those two sides are congruent. Therefore, we know we have an isosceles triangle. This angle is x degrees. This angle up here is 3x degrees. So that's the information that we know. And just like I said when we were dealing with the isosceles triangle, the first step here has to be to write an equation. I'm trying to find the measure of that angle. I know it's 3x degrees, but that's not a measure. I need an actual number, like 46 degrees. So how do we start? My first piece of advice is to look at that third angle and see what we know about it. Over here, there's nothing marked. But this is an isosceles triangle, so that means we've got 2 equal sides and 2 equal angles. These are the base angles here, right? This is our base, and these are the legs. And so the base angles, this one and this one, have to be the same. If this is x degrees, this is x degrees. So that's the first thing I know. The other thing that I know here is that this is a triangle, and the 3 angles in a triangle have to add up to 180 degrees. So I'm going to write that out. I'm going to write the measure of angle R plus the measure of angle T plus the measure of angle S has to equal 180 degrees. So that's just a fact that we know about triangles. It's not necessary to write this out, but I think it's a good thing to have in your notes. And what I'm going to do now is replace each of these with what we know about it, right? So angle R is x, angle T is 3x, and angle S is x. And so now I have an equation that I can solve. So let's go ahead and do it. These are all like terms. We have, remember, 1x plus 3x plus 1x. 1x plus 3x plus 1x is 5x, so that whole thing just becomes 5x equals 180. Go ahead and finish solving the equation. I just did that without a calculator, so I'm going to double check and make sure that I'm right. Hopefully I am, but hopefully x is equal to 36. So what I'd like for you to do now is go read the question that was asked and answer it. So I'm going to ask you to pause the video. We know that x is 36, and the question was find the measure of angle T. So go ahead and pause the video, work it out, come back to see if you did it right. So I don't think this is a particularly difficult problem, but one of the things we're really going to be focusing on in class when we practice this lesson is communicating your thinking on paper. It's really important that you write this equation out. It's really important that you show the correct solving process and that you then don't just write 108 and put a box around it, but explain where that's coming from, right? So the measure of angle t is 3x, show the substitution, and show your answer. So please make sure you're doing all of those steps. Let's try another example. Example 3. In example 3, we are going to find the measure of angle P. We're going to draw this time sort of a diagonal line just to change it up a little bit. So sort of a slanty line. And then kind of eyeball the midpoint. Make a dot, and then go ahead and connect that vertex to the two sides of the base, I guess I should say. And we are this time going to say that these two sides are congruent. We have P, Q, R. Angle Q is 3x plus 3 degrees. Angle R is 5x minus 2 degrees. And we're looking for the measure of angle P. So what's difficult, I think, about this problem is identifying the base, because we need to know what the two base angles are. And so since these are our two legs, that means this has to be the base. Sometimes it's helpful to write that in. That has to be the base because these are the legs. Those are the sides that are congruent. And that means these are our base angles. So we know that this angle is 5x minus 2 degrees. We know that this angle is 3x plus 3 degrees. And because these are the base angles, this has to be the same. So that means this is also going to be 3x plus 3 degrees. And now, just like we did before, we know that the measure of angle P plus the measure of angle Q plus the measure of angle R has to equal 180 degrees. And so you now can replace those three with the three expressions from the problem and solve the equation. When you're done with that, you won't be totally finished with the problem. You'll know the value of x, and then you're going to have to plug it in to find the measure of angle P. So at this point, please go ahead and pause the video. I'd like to see if you can finish this completely on your own. And then when you come back, the answer will be revealed. So pause now. So welcome back. I'd like for you to take a couple minutes here and just look through my answer. I got that x equals 16 and that the measure of angle P equals 51 degrees. It's really important that you do two things. First, you check to make sure you got it right, and that if you didn't, you look through and figure out what went wrong. It's also really important that you make sure that your work looks like mine. It's really necessary here to be able to really see, when I look at your work, how you found your answer, not just that your answer is correct. So please make sure that you did a really thorough job of showing your work. And then when you're done with that, go ahead and write your summary. I started it for you. It should say, to solve problems involving equilateral and isosceles triangles. And then you go ahead and finish that, that sentence, and then you're all done.